All right, welcome to my secure network at architecture room. Sorry about that. Alrighty, so the first task is going to be the introduction. So this is going to be a brief overview of what we are about to dive into. Moving on to network segmentation. So the Ethernet data frame, along with the VLAN data frame right here, gives you a little picture to go off of, and a brief explanation in a sense. Moving on, tagging unknown traffic. The native VLAN is used for any traffic that is not tagged and passes through a switch. To configure a native LAN, we must determine what interface and tag to assign them, then set the interface as a default native VLAN. Below is an example of adding a native VLAN in an open switch. So, right here. Alright, on questions right here. How many trunks are present in this configuration? So it's going to be 4 trunks. And what is the VLAN ID tag for interface Ethernet 12 or ETH 12? And it's going to be 30. Common secure network architecture. So zone eternal, DMZ, trusted, restricted, management, audit. Explanations and examples. From the above table, what zone would a user connecting to a public web server be in? So it'd be external because you're not at your home IP address. From the above table, what zone would a public web server be in? It's going to be DMZ. From the above table, what zone would a core controller domain be in? Restricted. Network security policies and controls. So traffic filtering using an ACL. Access control entry, so it's kind of like a bottleneck in a sense for the bases. And an ACL is a access control list, kind of like a queue almost. So these are commands right here that are set up to restrict people from just connecting to a switch and potentially abusing the system. Right here's some more code denying an entry into a switch to, again, prevent abuse of power. Analyzing packets and ACLs. According to the corresponding ASL policy or ACL policy, will the first packet result in a drop or accept? And it would be an accept. And according to the corresponding ASL policy, will the second packet result in a drop or request? And that second one would be a drop. Zone pair policies and filtering. So firewalls and zone pairs. Firewalls, stateless, stateful. Those are the two uh, kinds in a sense, along with um, shoot, I forgot that last one. But these are the two that are going to be used regardless of location. Uh, and this is covered in extending your network room as well. So zone pairs, they are direction-based and stateful policy that will enforce the traffic in single directions per each VLAN, hence zone pair. For example, DMZ, LAN, or LAN DMZ. Moving down, this is going to be a table giving you the Zone A, Zone B protocol and action. Not all traffic is an IPv4. Depending on your network configuration, you may also need to configure an IPv6 rules as well. Creating a zone pair from scratch. So, Sources, destination, protocol, action, default action. What is the flag found after filing and all the blanks on site traffic? So the flag is going to be THM, mostly secure, violating or validating traffic network traffic. Alright, so begin in this task. Let's first start with a scenario. Your organization has proper zoning and routes in place. A zone pair between DMZ and LAN allows an HTTPS connection. Of course, the firewall should accept these connections. How else is Susie supposed to watch Facebook on your Azure updates install? In the scenario, let's find that there is a threat actor that has landed an implant through phishing on a LAN machine. Assuming host defense mechanisms have failed, how can the implant be detected and monitored? If their beacon is using HTTPM or PS through their DMZ, that will look like primarily legitimate traffic to your firewall and analysts. To solve this issue, you must use SSL and TLS inspection to intercept HTTPM or PS connections. And it gives you an explanation of the SSL and TLS inspection methods. So, does the inspection require a man-in-the-middle proxy? Yes. And what platform processes data sent from an SSL proxy? And it's going to be a unified threat management. Moving on to addressing common attacks. So, snooping is going to be a big one. And you would find the snooping with a dynamic ARP inspection. And Cisco is the one that defines the ARP inspection. Giving you some examples right here of a diagram showing a valid ARP request that matches both the binding database and request information. And this is a invalid ARP request that does not match the binding database. Where is the DHC? Snooping, source least IP. Sorry about that. Least IP addresses from untrusted hosts. So it's going to be the DHCP binding database. Will a switch drop or accept a DHC pre-release packet? So it's going to drop it. Does a dynamic ARP inspection use the DHCP binding database? Yes or no? Yes, it does use it. And dynamic ARP inspection will match an IP address with other packet details. So it's going to be, question's worded a little funny, but the answer is MAC address. And this is the conclusion. Thank you for watching my Try Hack Me room. Please come again.